predict the hydrology event that will occur at the agricultural area. Next is the research aim. The research aim here is numerical weather parameter forecast to support agrometeorological information system for small-scale agriculture in tropics. Numerical weather parameter forecast here is meant by is a method that enable quantitative calculation of time variation for meteorological elements, which is the parameter to estimate the prospective value. The agrometeorological information system here means is used forecast model that relate with the parameter that will help the farmers. The objective of this study, there are three objectives of this study, which is to propose a data fusion technique or algorithm that is adaptable and suitable for agriculture need in tropical climate. Second, to develop a data fusion technique or algorithm as in objective 1. Third is to evaluate the catchment area, providing sufficient lead time using appropriate measurement. Next is the scope. The purpose of the study is to implement data fusion technique in weather forecast and suitable based on agriculture need. The study area covered in this study is Batu Pahat, Aitam, and Keluang. The theory that will be used in this study is artificial neural network, adaptive neurophazy inference system, and multiple linear regression. The sample of the study is the parameter used, which is wind speed, pressure, temperature, and humidity. This study expected to have a new finding, which is new finding about data fusion technique to predict the environmental condition and having a potential application in smart farming decision support system, environmental forecasting. Next is the literature review. In the literature review, there are 5 fusion techniques that I will cover. First is artificial neural network, based on Tabusum and DAR, Lekas, and SB. It shows that by using artificial neural network, the result can get high accuracy in weather forecasting. For example, based on Tabusum and DAR, they implement all the method, compare between each other, and the result is Levenberg Marquardt performed the best accuracy in a weather forecasting. Based on Lekas, Elman and Adeline proved that by using artificial neural network can accurate the forecast in water quality tool management. And based on SB, the model has a strong forecast model for a food peak with forecast horizon of 1 hour. Next is adaptive neurophazy inference system. Based on when it is difficult to assess the available extreme precipitation record and to integrate them with the finding of the flood simulation model. Based on Razali, the accuracy can be described through the plot pattern which less overfitting brings the best result. MLR model is suitable for simple problem, but by using NFIS, it can give it can solve the large problem. Based on Firat and Mahmoud, the finding indicate that by using NFIS approach is superior than the ANN and MR method in the modeling or and forecast of the river flood. Next is the fuzzy logic. Fuzzy logic is the technique used for fuzzy logic is have a limited number used for in the forecasting based on FAHP, which is fuzzy analytic hierarchy process, is having limited number used in flood risk management. And based on Jana and Thomas Kozel, by applying fuzzy logic, it is hard to detect which area have flood risk flood forecast. Next is multiple linear regression. in the multiple linear regression, based on Zhang, the prediction only for high flow signature, but not low flow and dynamic signature. Based on Chen-Niha, the performance of SDSM using multiple linear regression is strong on monthly basis for potential rainfall prediction under HAD, CM3, A2, and the B2 pollution case. And based on Patel, by using M40-60 scenario, the model can estimate the stream flow better than other simulation. And lastly, multiple nonlinear regression. But multiple nonlinear regression is quite unfamiliar being used for the weather forecasting. But based on Rezanzadeh, the results show that by applying NFIS is more accurate in maximum daily flow. First, load the training data, set the input parameter membership, and then training the NFIS. And during training NFIS, during the training process, the membership, the parameter membership is being modified to get the best FIS after training. FIS here is fuzzy inference system. After get the best FIS after training, input the machining parameter for prediction, and then get and FIS for predict the result. For multiple linear regression, data is being normalized and then calculate the regression coefficient. But to calculate regression coefficient, need to transform it to matrix and then calculate the coefficient in through the matrix, and the input value of each coefficient to the regression equation, and from regression equation, and from the regression equation, it can produce an error value can be obtained. Next is a Gantt chart. First, I start with the background study, and then I continue with the data collection. After that, I doing a evaluation of the data, and it is categorized into two parts, which is testing with computational approach for fusion data, and agriculture management and decision support system for agriculture need. And then the outcome is being evaluated. If not, if no data is being evaluated, then repeat to the start data collection. If yes, result finding and conclusion, make a report writing. This is my reference for my based on my thesis study. Thank you.
Thank you, Najiha. Dr. Said, you want to start first? Yeah, you need to turn on the microphone, Doctor.
Okay, thank you, Doctor. Thank you, Doctor. Thank you, Najiha, for your presentation. I just want to highlight a few points, which I do believe that it will improve your work. First of all, I would like to say, choosing the topic of NFIS for predicting the climate change for agriculture purpose is a nice topic, honestly. I even check. I saw like this type of research, like being recent research, 2019, 2018, something like that. But few things, and I even supervised similar before similar topic of you using NFIS, but for power system. For power system, they use it to detect and predict the faulty transmission line using NFIS. Okay, so it's a prediction method. But I want to you to highlight few things you should highlight in your research to make your research, the contribution, more clear and more convincing. If you do that, one thing, this is a hybrid solution, so you have to focus on why this hybrid solution is better than fuzzy logic and better than ANN, and when we both put them together in ANFIS as a hybrid solution is better than both. This is very important to show the unique of your work. And even though you still have another level to show your contribution also, you can say that this ANFIS application, if we use it for climate change in Malaysia, it will be very beneficial, because ANFIS used in other research also to predict climate change. But if you use it in tropical area, like in Malaysia, in certain area, maybe it will be like very beneficial. So this will be added to your contribution. So as a short or in a brief, 2 points, please clarify. Clarify why this hybrid solution is better than ANN alone, better than fuzzy logic alone, and why it's also good for tropical region and for Malaysia region. This is also important. This depends on your data set. So you have to describe the data set you take, you describe the data set you take, and you show that this hybrid solution working very, very good in this type of data set. Okay. Okay. So just for your information, just very briefly, ANN is not easy to understood for a human, because actually the decision is made internally inside the architecture of ANN. But when you put with a fuzzy logic is like near to human reasoning, using rules. So that means like it makes your system more explainable and not very, more explainable for a human. So that's also like the power of ANFIS. Okay, so this is just suggestion. Few things you have to clarify. For example, in your title, you use small scale. What do you mean by small scale, and how you define small scale? You didn't touch on that. This is important because it's in your title. Is small scale. Yeah. Okay. Another thing, maybe objective 1 and 2 should be combined together, because I don't feel like, or I don't see that they are different. So objective 1 and 2. It came to my mind one suggestion for you. It can leverage your work really to very good level, if you're able to do that. You know, satellite scintillation. The concept of satellite scintillation, because actually satellite scintillation is used to predict or to use for prediction of weather in real time. And there is a data set. Luckily, there is a data set. You can go UKM. You can find Malaysian data set even. Some Malaysian data set, satellite scintillation. Actually, in satellite scintillation, they collect data in real time, maybe for 1 year, seasonal data even for 1 year. They collect this data and they predict from the satellite signal, the received satellite signal, how maybe the climate changing in real time. So if you're able to combine satellite scintillation data with ANFIS prediction, it will be like much more interesting, honestly. And it will leverage your research to a higher level also, like, because you combine both satellite scintillation and and fees for prediction. In this type of training model, the accuracy is very important. You have to highlight the accuracy. So what type, like in different criteria, in what type of prediction accuracy you already achieved? Okay, so these are some of my comments, which I do believe like some you have to justify, some maybe objective you have to combine. Data set is very important. I suggest to use as I told you, satellite scintillations data, which can be found in Malaysia, can be found in UKM and UTM, even they have satellite scintillation collected data. So maybe you can use that also. And please highlight the architecture, not only the flowchart, the architecture of fuzzy logic, especially the rules in fuzzy logic, which combine also with the architecture of ANN, and why the hybrid solution is better than both, and why this is better for certain data set. Okay, so that will make your research, in my opinion, more justifiable, and you leverage the level of the research to a very interesting level. And that's all what I can say. Sorry if maybe for Dr. Noor.
Okay. Thank you, Dr. Syed. I think very valuable input from Dr. Syed, I believe. I don't have much comment for you, Najiha. I just have a few things that I think need to clarify here, because I might have missed some part of the presentation, but from my understanding, you are doing the prediction of using ANN, additive new fuzzy, and multiple linear regression. But from your presentation, what I learned is that you want to do analysis on this different approach to see the performance on the agricultural data set. Am I right?
Yeah, right.
Okay, so you is it you want to do it? You wanna just do the analysis on different this different approach, or you want to combine these three into a hybrid system? Because it doesn't show anywhere, probably because of the architecture is not there, like Dr. Syed mentioned just now. So I couldn't see really well what you want to do exactly in this research.
Oh, actually, I will be compare the three method, and the result is if the result I get will be the accuracy, the value, not the by the graph, because I use numerical weather parameter forecast. That,
So you just want to compare between this different approach on based on the those parameters that you have selected at the beginning of the presentation, right? So
yes.
if that's so, I think probably you need to discuss again further with your supervisor, because I don't know if this is going to be sufficient for master level, I mean master by research level, just by comparing and doing analysis of performance between different methods, and without you doing contribution. Not really. Your analysis is contribution. I understand that, but normally for masters by research, we expect that student will do some kind of like at least improvement or enhancements on some approach. Okay, because we have some demarcation line that we have to follow. So I'm not really sure that this it should be sufficient for the master by research level. So can you discuss further with your supervisor?
I will discuss with my supervisor.
Okay, because initially I was a bit confused whether you actually want to do this separately. You want to compare the performance, or you actually want to hybrid all these three methods into one, or like Dr. Syed has been explaining just now. So it obviously shows that you just wanted to compare these three, right?
I will be proposing the model for accuracy.
Okay, so it is actually a good research, but then you have to understand that we have some some standards that we have to follow to differentiate between master by level and master by research, master by coursework, mixed mode, and all that. Okay, and another question is about data collection. Do you have in mind what sort of data collection that you need to do in the future?
I will be collect the data from meteorological department, irrigation department, and agriculture department, and the data I will be collected. I will ask about the based on the parameter relate with the weather forecast.
Okay, I think that's all for the.
I just want to add one comment. Sorry. Thank you very much, Dr. Noor. The hybrid solution, and FEAS is a hybrid solution. So if you want to compare, you compare in architecture. You show the architecture of ANN, you show the architecture of fuzzy logic as reasoning based on rules, and then you work in and FEAS as a hybrid between both. So you compare maybe in architecture that you show the hybrid solution is better than both having advantage, because everyone like having advantage, disadvantage, but like FEAS is more advantage than both. If you connect that with the architecture, you explain that in architecture, that will be enough. I think you no need to compare in terms of performance evaluation for the three models. It not make sense too much, because FEAS itself is a hybrid solution and it combines the advantage of both, of the ANN and the fuzzy logic. So for that, they call it adaptive neural network something, FEAS. So compare in architecture to justify why you use FEAS, okay? And then, as I told you, connect with the data set of interest. Data set really like is suitable for FEAS, like maybe as I suggest to you, satellite scintillation. As I see the proposal, the proposal or the idea is interesting in my opinion, but you not understand the architecture yet. So you have to understand more deeply the theory of the architecture and why you use FEAS and why this hybrid solution is better than ANN and fuzzy logic, and why it's also very interesting for certain data set, let's say satellite scintillation as example, in my opinion, just suggestion for you, satellite scintillation, it can be combined with that and it can give real-time prediction of the climate in good accuracy and explainable also. If you do that, I think it's okay. It will be like okay for your work. That's what I want to add. Thank you.
Okay, thank you, Najiha. Then thank you, Dr. Said.
Thank you.
Okay, thank you, student and panel. Student, please take note all the valuable comments from the panel to pursue your research. Okay, so thank you. Now we go to the last presenter in this morning session. Ms. Fatima Az-Zahra, and the panel will be Dr. Muhammad Farhan and also PM Dr. Nurhaniza. Okay, so please, you may start the presentation now. Thank you.